Hello everyone! We've finally reached the video where we'll be exporting this rigging data to Unreal Engine. In today's video, I'll show you how to export the data we've been working on to Unreal Engine and set up metahumans correctly. Before we begin, we'll need an Unreal Engine project file that includes the metahuman template. This can be the official metahuman template project from Epic Games, or you can use the free template file we provided. Great, let's get started. First, we'll put all the meshes related to this character's clothing into the Geo group. We're going to export the items inside the GRP Geo group. We'll do the same for the hair and put it there as well, so this is what it should look like. Last time we copied the skin weights for these outfits. The shoes haven't been done yet. Let's go ahead and copy the skin weights for the shoes as well. See? It's really easy to attach them like this, right? Alright, no issues with other parts. Now, select the character body LOD group and move it along with the topmost root joint out of the outliner. To unparent, press Shift plus P. For now, we won't touch the clothes. We'll only export the LOD group that contains just the body LOD and the joints. Select both of them and ensure the entire hierarchy is selected. Next, go to File and open the Game Exporter. Change the mode from Export All to Export Selection. Make sure to uncheck the checkboxes for Enable Media and Input Connections. Set the export path by creating a dedicated FBX folder. Name the file appropriately so that it's clear it's the body part. Once again, ensure the entire hierarchy is selected. Now, click Export, and the FBX file will be created in the specified path. Alright, after exporting, let's return everything to its original state. Place the root joint into a new group. Then open the head group and move the LOD group related to the head and the root joint within the head group out of the outliner. Remember, the root joint we're moving out now is the head's root joint, not the body's. Don't get confused? As before, select the entire hierarchy and export an FBX file for the head. Ensure it's the head root joint. If the head root joint isn't set up, refer to the previous tutorial video. Once exported, restore everything to its original state. Also, move the body root joint that was temporarily placed in the new group back to its original state. Let's turn on the metahumanSet tool. We are now going to extract the RBF poses for this character. Normally, metahuman requires exporting the RBF poses for each joint as separate animations, but I will export all the RBF poses for all parts at once and bring them into the engine. Simply put, an RBF pose key is a value that bakes the degree of correction for each joint into keyframes, which are then used as pose assets in Unreal Engine. Clicking the Bake All UE RBF Poses button will automatically find all RBF poses and bake them as keyframes on the driver joints in the timeline. When the key bake is complete, the current timeline will automatically adjust to match the key range. And you will see that all the information from the RBF nodes in the Pose Wrangler has been baked into keyframes. Great. This time, we only need the body root joint since we're extracting animation data, so we won't include the mesh. As before, select the entire hierarchy and give it a name that indicates it is a pose. Make sure to check the animation option and enable the advanced settings by checking the Edit Model Advanced setting. Check the Bake Animation option and ensure it matches the current timeline. At this point, most of the settings are configured. Make sure that both animation and bake animation are checked. When you export, the movements of the current root joint will be baked into keyframes and exported as an FBX file. Now, let's move on to the engine settings. Create a dedicated folder for your character. Then place the assets from the Unreal Asset folder I provided into your project's character folder. It should look like this. Each of these assets is important. We'll use the pre-configured pose animation blueprint to set up the correct metahuman control rig. First, let's import the body we exported earlier. Ignore other settings for now and ensure the skeleton is set to the metahuman base skeleton found in the metahuman common folder. We won't create new materials separately. I'll use the materials from the existing template. In the Mesh's advanced settings, set the normal import method to import normals and tangents. Also, check the box for import mesh LODs. Then, proceed with the import. For the material socket, we'll use the materials provided in the template. Great. You may not have noticed it at first glance, but if you take a closer look at the wire flow of this character shader, you'll see something a little strange. Do you see the zigzag pattern? This happens because the engine doesn't calculate the UV coordinates accurately when building the skeletal mesh. To fix this issue, go to the Asset Details and open the Build settings. Check Full Precision UVs here. While you're at it, also check High Precision Skin Weights to ensure that the skin information is calculated with more detailed decimal points. Click Apply Changes to apply the settings to the current LOD. This setting is currently applied only to LOD 0. Since we can use high quality up to LOD 1, let's apply it to LOD 1 as well. Now, let's bring in the head. This time, set the skeleton to Face Archetype Skeleton. It should also be the one in the metahuman common folder. Make sure to check Import Morph Target. Import Mesh LODs should, of course, also be checked. For the normal import method, it's best to set it to Import Normals and Tangents. Now, let's go to the Build settings again. It's the same process. First, set the UV and Skin Weight precision for LOD 0. For the face, we have a total of 8 LODs. Since there are quite a few, we'll only set LOD 0 for now. Let's scroll down. Set the default animation rig to Face Control Board. For the Pose Process animBlueprint in the Skeletal Mesh section, we'll adjust the blueprint later and add it here. Let's start by renaming the blueprint to match the current character. The same goes for any blueprints related to the face. Make sure to rename them to match the current character. We'll also rename the pose asset accordingly. It's important to note that you should only use the files I've provided to avoid any issues later on. The pose asset naming in the files I've uploaded differs slightly from the actual metahuman pose animBlueprint. In my setup, a single pose asset reads all joint names at once, whereas the actual metahuman setup uses multiple pose assets. So please make sure to use the ones we've provided. Now, we're going to copy the metahuman character blueprint and rename it to match our character. It doesn't matter which metahuman character blueprint you copy and use. You can use the official blueprint template from Epic Games, and it's okay if you don't use the one we provided as a template. Once you've copied the blueprint, let's go inside it. You can ignore the existing character form. Go to the body section. And replace the skeletal mesh with our character. In the viewport, the change might not be immediately visible. Don't worry about it and just make the replacement. We'll do the same for the face, switching it to our character. Click Compile at the top, and then close the blueprint. Open it again, and you should see that it has been updated to our character. Let's delete the existing skin cache usage settings and start from scratch to show you how to set it up properly. Configuring this is very important. Index 0 indicates that you want to refresh the skin cache for LOD 0. I'll set the skin cache to refresh up to LOD 3. If you don't set this up, you might encounter issues related to normals when the character deforms. While not setting the skin cache for the body might not cause significant problems, the face can have issues with the existing normals when parts like the eyes and mouth move too organically. Think of it as a way to prevent that kind of problem. Since the head currently doesn't have any materials applied, let's replace some materials using the existing character. If your materials aren't properly divided by ID, please refer to the previous tutorial on how to automatically apply materials. All right, everything is set now. Let's temporarily place our blueprint character onto the level. The LOD is applied automatically, so when the camera moves further away, it shows lower LODs, which is why the materials might briefly disappear. I haven't added materials to the lower LODs yet. Now, let's turn on this poseDset tool for a moment. This tool automatically sets the skeleton coordinate information of the current character in the post-process animBlueprint, where the poseDset is applied. First, select the character in the level. We are going to fix the path issue in the body animBlueprint by redefining the skeleton. Right-click and select Assign Skeleton. Choose MetaHuman Base Skell. This way, the animBlueprint finds the skeleton and the path is fixed. Similarly, we'll assign the skeleton for the face animBlueprint. For this, choose Face Archetype Skeleton. In the content browser, select the animBlueprint. Click Get, and it should be automatically recognized in the tool window. If both of them are correctly detected by the tool, click Set poseDriver Init Value. Now, let's open the animBlueprint. Change the preview to our character and save it using Apply to Asset. If you're in animGraph preview mode, turn it off and on again. When you click on a poseDriver, you'll see that the default value is filled with 100 and appears in red. If it's not 100 and shows a different value, try turning it off and on again. Make sure the preview is set to your character. Some poseDrivers might not show a red indicator, but don't worry about it too much. As long as it's not showing in purple, it's fine. The red 100 indicates that the current pose value is red as the default. This means that the character's skeleton coordinates have been properly read and saved as the default value in this animBlueprint. Now, select all the poseDriver nodes, but don't select the captions behind them. As you scroll down the detail section, you'll see what poseAssets are being read. Change these to those of our character. Then click Compile. Great. Now we're going to import the pose animation that we exported as an FBX earlier. Set the skeleton to metahuman-base-skell. This FBX file doesn't contain a mesh, so there's no need to worry about mesh-related settings. We only need to import the animation correctly. When you import it, things might look a bit off, right? What's going on? First, let's change the preview to our character. Now it looks even stranger, doesn't it? Turn it off for now and open our character's pose asset. If you can't see the Asset Details panel, make sure to open it from the Window menu. Change the retarget source asset to our character. Be sure to click Update as well. Now, replace the source animation with the file we just imported. Make sure to click Restore Source and save everything. This process takes the animation's keyframe information and converts each frame into a pose, assigning it accordingly. We previously changed all the pose assets in the body animBlueprint's poseDriver node, so this setup ensures that everything works smoothly without issues in the control rig later. All right, now let's open the animation sequence data again. It still looks strange, doesn't it? Let's change the retarget source asset to our character. Now you should see it appearing completely normal. This animation is not something we had originally. It's the animation we exported from Maya at the beginning. Don't get confused. We're almost done now. Go into the body skeletal mesh. Set the default animation rig to metahuman control rig. For the post-process animBlueprint, use the animBlueprint we set up earlier for our character. When you apply this, temporarily disable the post-process animBlueprint. If the character's form doesn't pop or change, then it's applied correctly. If any part of the character's form pops or changes, it means that the joint axis align wasn't done correctly during the initial rigging, or the skeleton coordinate values weren't registered properly in the animBlueprint. If I set this with another animBlueprint, it will always pop like this. This is because the skeletal coordinate values applied in the animBlueprint do not match. Now, let's open the PSD tool again and apply it to the head this time. Open the head animBlueprint first. I'll change the preview. Oh, it looks like a bug. No worries. Just compile it again, and it should be resolved. This process is exactly the same as what we did for the body earlier. First, register the blueprint character and the head-related animBlueprint that exist in the level. Then, just click Set. If you compile it again, it's not showing up in red. That's okay. It's not an issue if there's no reaction. As long as it's not showing in purple, like I mentioned earlier, you can simply set the pose asset here with the existing neck-related pose asset. Now let's go into the head skeletal mesh. Set the post-process animBlueprint to the animBlueprint we just used. There's not much difference here. Very good. Now let's briefly check the metahuman AR kit animation of this face. The existing one works fine, right? But strangely, ours doesn't seem to read the animation properly. In such cases, right-click on the character's face skeletal mesh and try replacing the metahuman DNA. Currently, it automatically selects the body, but you need to be careful. Make sure to select the skeletal mesh for the head. Don't worry about the asset preview. Once you've imported the DNA we worked on in Maya into the engine, let's check the RKit animation again. Yes, now it's reading the DNA correctly. If you've made it this far, you've done a great job. We're almost done now. I see that when the character blinks, the mesh normals appear incorrectly. For now, I'll create a temporary level sequencer in the external folder. Let's place this character blueprint here. Do you see that a control rig is automatically created? When I move the face controller, it doesn't seem to work. I think the current character blueprint placed in the level isn't reading the DNA correctly. In this situation, you need to temporarily delete the character blueprint from the level and add it again to check. Just because a blueprint exists in the level doesn't mean it updates all information in real time. Sometimes you need to restart the engine or add it again. In short, it's just a bug. You'll notice that when the eyes are closed, the normals appear dark, just like before. This issue is more common with facial expressions than with the body. In actual metahumans, this is corrected using vertex color, but we'll fix it using a simpler method. Go into the character's face skeletal mesh. You'll see a section labeled Section under LOD0. Change the recompute tangent value of the face material to all. Remember that we previously enabled skin cache on the facial skeletal mesh in the character blueprint, right? You need to make sure that setting is enabled too. This ensures that movements appear without any issues. Oh, it looks like the mesh exploded. That's okay. Just turn the sequencer off and on again. And there shouldn't be any problems. Now, you can see everything is working without any issues, right? Not only the face, but the joints on the body are also properly adjusted and can be moved in real time with the control rig. When the character is far away, it switches to a lower quality LOD, so let's set a few of the lower LODs with the same settings as before. If you notice any strange issues with the character, just turn the sequencer off and on again. Let's try out a few more actions. At this point, some of you might have questions. How do you attach clothing? First, move the group containing the clothing meshes to the outside. The process is similar here. Select the body root joint and clothing mesh, then export them one by one. Let's create a folder specifically for clothing. Anything related to the body should use the metahuman base skell. The other settings are similar to when you imported the body. I'll import pants and shoes in this way as well. All right, now we just need to open the character's blueprint and insert these skeletal meshes. The torso here will be the sweater. And the legs will be the pants mesh. The feet will be the shoe mesh. Once you've replaced them, click the Compile button and save. These skeletal mesh components don't automatically follow the body animation just by being imported. If you look inside the construction script, you'll see that all the skeletal meshes registered in the current blueprint are set to follow the master pose. If you want to add skeletal meshes like hats or accessories, you'll need to add the skeletal mesh components to this blueprint and set them up separately, just like in the construction script. That way, they will properly follow the body animation. Let me demonstrate. We haven't imported our character's hair mesh yet, have we? I'll export it the same way as before. By the way, for separate objects with fewer skin influences, you can manage them with a simpler skeleton structure without any issues. Once you've exported it, come to the construction script and copy any of the existing setups. At this stage, add a skeletal mesh component. I'll name it hair static. You can link it the same way as before. Now, we need to connect the hair skeletal mesh, right? Oh, I forgot to import the hair. Let me bring in the hair FBX file. Now I'll connect the imported hair to it. Compile and save. And you'll be able to see the character with the applied changes. Even if your hair has a joint chain or a different skeleton, there won't be any issues as long as you set it up like this. So, this concludes all the lessons on transforming your character into a metahuman. Thank you very much to those who followed along and to those who watched until the end. Even though we provide tools, the entire process of accurately converting your character into a metahuman was probably not smooth sailing. This entire process is quite challenging, so don't think, why isn't it working for me? Just take your time and follow along step by step. If you have any questions, please feel free to reach out to us at any time. Thank you for watching this difficult tutorial, and we will share more helpful tips next time. Thank you.